in question 3. Oh boy. Okay, define an NB list. NB dash list. To be a list that's empty or has elements, numbers, booleans, or NB lists. Okay. So it can be empty or has nums, bools, and B lists inside. So this seems like a recursive procedure, or recursive kind of structure here, right? Where similar to your B-ands and B-nots, they can kind of be inside of each other. I'm not sure if you've gotten to that piece yet. If not, don't worry. Okay, define a recursive racket procedure numbers list that takes an NB list and returns a list of all the numbers that occur in it, left to right, in the left to right order in which they occur, preserve duplicates, use only built-in racket special forms and procedures, blah, blah, blah. Do not write any auxiliary procedures for this problem. So I'll write out one of their examples is NB list, is it? Oh no, it's called numbers is the procedure, oops. I'm gonna call it nums here just for brevity. So they have false, 1, 2, empty, 1, and this returns, of course, 1, 2, 1. Because it gets this number, and this number. Okay. All right. So this seems pretty similar to tree recursion to me, where we're going to have to, I'm going to move over a little bit because I think I might be cutting it off, where we have to go deep into the lists until we reach base cases of either an empty list or something that's not a list, a leaf. So I'll start writing my procedure with my base cases. Define nums. You don't want to abbreviate like this on your test because you might get points off. I'm just doing it so I can get through this video alive. Define nums, takes an NB list. Maybe I'll call it LST just so we don't get confused with the struct. Or it's not a struct, but just bear with me. And then I'll say, if if empty, NB LST. I'm just going to output empty list again. And then also I'm going to go through oh no, because I have to split it up into if I see a list, I should recall this. Well, that's how I'm going to do this. So I'm going to say if I encounter a list, run this procedure on the car and the codr of the list and then append those together. Does that work? Procedure in the car and the codr, run those together. Or just, what if I run this procedure on the entire list itself and then I append that to my eventual output? Because this function, nums, gets all the numbers from an NB list. Any list inside here must be an NB list. So I can just run this procedure on this list, get all of its numbers, and append that to my output. Okay, I hope that made sense. If it didn't, I think we'll get there in the code. So I think this works, this base case. If empty, NB LST, return empty list. If it's not empty, I'm going to ask if the car is a base case. So I'll ask something like if, or maybe I'll have a cont here. What would I return if it was empty though? So if I have like an empty list here, then what am I going to do with that? Oh, I know. I'll just treat empty lists. I'll just make sure I'm appending all my outputs so that even if it's an empty list, it won't add any elements. Okay, I don't know if that made sense. Hopefully my thinking is making some sense. If I encounter an empty list, what I'm saying is that I'll just append an empty list to my growing kind of, my growing list of stuff I'm matching onto the eventual output of this empty list. I think it'll end up making sense. So I can say something like, if list car NB list. So if the car of my NB list, like this guy, is a list, then I'm going to say append nums on the car NB LST, append nums on the car to the recursive call, which in this case is just going to be nums on the cdr of NB LST. Okay, so here I'm closing this, I don't want to close my append. I don't want to close my if yet because I need the condition for if it's not a list. If it's not a list, I'm going to say if number car LST, if number car LST, append, in this case I can just say cons, I'll say cons car LST to my recursive call, which is going to be nums cdr LST. So cons car LST is in parentheses, nums cdr LST, close my cons, don't close my if yet. Else, if it's not a number, I don't want to put it in my eventual output list. So I'll say else, just run nums on the cdr of the list. So I'm closing nums, closing this if, closing this if, closing. Do I have? So if it's empty, yeah, I'll close this if, I'll close this define. Okay. That was a little bit messy. But what I'm basically saying is if the first element of the list is empty, return empty list. That kind of makes sense. Oh, sorry, if my entire list is empty, return empty list. If it's a list, even an empty list of the first element, then run this function recursively on it and append that to this function run on the rest. So both of these will return lists, and it'll append them together. If it's an empty list, this first one will just say append an empty list onto this run on the cdr, and that's fine because the empty list doesn't have any numbers we want to include. If number car list, then of course cons it into the recursive call. And if it's not a number, then you just recurse on the rest of the list. 3b asks me to draw a tree of recursive calls without return values for my procedure from part 3a when I evaluate this funky example they have of nums list true 1 and then 4, 5. List true 1, 4, 5. Okay, so all I have to do is remember what I coded over here. I said if my entire list is empty, return empty list. It's not yet, so this is going to call nums on, well, let's see, is list the car of the NB list? It is, so it's going to run append on nums on the car and nums on the cdr. So this we'll call append nums true 1 to the output of nums on the cdr, which is 4, 5, close parenthesis. This guy here will say, it's not empty and my car is not a list. Check if my car is a number, it's not. So this will say, just call on the cdr, call number on the cdr of my list, nums list 1. This guy will call, and here the first element is a number, so here it'll say cons 4 onto nums. Oh, am I getting cut off? Let me squish things over a little bit. This guy here will call, it's gonna get confusing. I'm gonna scoot over even a little bit more. this we'll call cons 4 onto nums 5. Okay, nums on 1 we'll say it's still a list. The first element is a 1, so cons 1 onto nums on the empty list. This guy will say, not that guy, but nums 5 will say cons 5, because 5 is a number, onto nums empty list. Nums empty list will return empty list. And these are my, I guess I don't need the return values here. These are the last recursive calls that are made. Nums on the empty list, and then, yeah, I think this is my tree of recursive calls. I don't think I even need the append here, or the cons is probably, because it's just asking for what the recursive calls are, not what's being done to them. But this is what my tree of recursive calls would look like if they passed me this input to my function I wrote. Move out of the way.